We are starting with the discussion on annuity. So let us revise this particular chapter. Okay, the second part of the chapter, that is annuity. So let us go to exercise 1.2 of your government textbook. Question number 1. Okay, so let us read the problem first of all. It's on page number 27 of your government textbook. Find the accumulated value of annuity due of rupees 800 for 3 years at an interest rate of 8% compounded annually. So C is the annuity. Annuity is always denoted with C. Okay, and they have clearly mentioned annuity of rupees 800. Okay, now we are supposed to find out future value. Now in this particular chapter, see, if the problem does not mention whether it is due or immediate, okay, so we always have to use immediate annuity. Okay, and future value in immediate annuity is A, but then in annuity due, the future value, accumulated value is A dash, right? N is equal to 3 years, so 3 years indicates 3 installments. Okay, and I, the rate of interest in this chapter is denoted with I, is 8% compounded annually, which is clearly mentioned in the problem. So A is equal to C by I, 1 plus I raised to n minus 1. So that is equal to 800 upon 8%. Okay, 1 plus 8% raised to 3 minus 1. So this calculation you need to do now. Now this 8%, I'll write it as 8 upon 100 at both the places. This is 8 upon 100. 1 plus 8 upon 100 raised to 3 minus 1. Okay, so this will be 100 goes at the top. So 800 into 100 upon 8, 100 plus 8 upon 100 raised to 3 minus 1. So this is 100 and this is 10,000. If you calculate this, this will be 108 upon 100. So there are two zeros, so decimal point will come over here and we'll have two decimal digits. This value is always given. The value will be given to you. Okay, so 1000 into 1.2597 minus 1. 1.2597 minus 1 will give you 0.2597. Okay, now 0.2597 can be written as 2597 upon 4 zeros. So 10,000 into 2597 upon 10,000. 10,000 as 4 zeros. So this and this gets cancelled. So this is equal to rupees 2597. So that was the first problem. Second problem I will not solve, but then we'll discuss it at least so that you can solve it at home. A person invested 5,000 every year in a finance company that offered interest compounded at 10% per annum. So the person is investing 5,000 every year. So it's not mentioned he is investing at the beginning of the year or at the end of the year. That's not really mentioned. So we'll consider this as this is the installment he is paying every year to the finance company. So the installment is nothing but annuity. We'll consider this as annuity immediate because nothing is mentioned in the problem. Okay, n is equal to 4 years, which is equal to 4 installments, right? Then I is equal to 10% per annum. Fine. So we are supposed to find out the accumulated value, that is the future value. The problem remains same. You have to use this formula C by I. Okay, 1 plus I raised to n minus 1. Fine. So this problem is same as previous. Let us go to the next problem. Question number 3. Okay. Find the amount accumulated after 2 years if the sum of 24,000 is invested every 6 months at 12% per annum compounded half yearly. So basically in this problem, the installment of 24,000 is taken from the investor, okay, by some finance company or financial services company. Okay, so this amount is taken not every year but then every 6 months, so twice in a year we are the person is investing this amount. Okay, so this problem becomes half yearly problem. Okay, we are supposed to find out a, which is accumulated value of, once again, um, the annuity due or annuity immediate thing is not mentioned over here. 24,000 is invested every 6 months. So at the beginning of 6 months, at the end of 6 months, it is not mentioned. So we'll consider annuity immediate itself by default. And annuity immediate is also called as ordinary annuity. N is equal to 2 years. So that is equal to 2 into 2, because in a year there will be two installments. So in 2 years there will be four installments. So whenever the half yearly problem is there, multiply whatever number of years are there into 2. Okay. So this is equal to four installments. So this is not 4 years. This is four installments. I is equal to 12%, but then divide this by 2. You'll get 6%. Okay. Then by this formula, A is equal to C by I, 1 plus I raised to n minus 1. Okay, you can use this formula and get the necessary answer. Fine, the formula remains same. The only thing that was uh, a bit tricky to understand was this half yearly kind of calculation. Okay, let us go to the fourth problem. Question number 4: find the accumulated value after 1 year. Okay, so we are supposed to find out the accumulated value after 1 year. Annuity immediate, of an annuity immediate in which 10,000 is invested every quarter. So see, annuity is of rupees 10,000. It is invested each and every quarter. Okay, so in 1 year there will be four installments. So n is equal to 1 year. So 1 into 4, because quarterly calculations we multiply time period, the number of years, into 4. And I, the rate of interest, will be divided with 4. So this is only for quarterly. Okay, so this is equal to 4%. And we are supposed to find out the accumulated value. Now this problem, certainly it is of annuity immediate. It is clearly mentioned in the problem. So we are supposed to find out A. A is equal to C by I, 1 plus I raised to n minus 1. This is same as the first problem that we solved. Same calculation. So you can practice this problem on your own. Okay, but then the critical thing to understand over here was, uh, when we have a quarterly problem, multiply the number of years by 4 and divide the rate of interest with 4. Okay, so let us move on to the next problem. Question number 5. Okay, find the present value of annuity immediate of rupees 36,000. So C is 36,000, the annuity, the installment is of 36,000. It is paid for 3 years, so n is equal to 3 years, which is 3 installments. The problem does not mention any half yearly, quarterly, so forget about it. They're asking present value, so that's P. Okay, of annuity immediate. So I'm not writing P dash. P dash is for annuity due. This is P, which is present value for annuity immediate, hence I'm writing P. Okay, I is equal to 9% per annum. So P is equal to C by I, 1 minus 1 plus I raised to minus n. Okay, so C is, I'll be solving this problem entirely. 9%, 1 minus 1 plus 9% raised to minus 3. Okay, now this is 36,000 upon 9%. Write that 9% as 9 upon 100. So this is equal to 36,000 upon 9 upon 100. 1 minus 1 plus 9 upon 100 raised to minus 3. Okay, this is denominator's denominator. This 100, it will become numerator. We can put it in the numerator over here. 9 ones are 9 fours are, that also we can do. Okay, now this will be 1 minus, if you calculate this will be 109 upon 100, which is 1.09 raised to minus 3. LCM 109 upon 100, so the decimal point will be after 1. Okay, all this basics I guess. Okay, 1 minus, now this value is given to you in the problem, so that is 0.7722. So 1.0000 minus 0.7722. So if you subtract this using normal subtraction method, okay, so this will be 0.2278. Okay, so 4 lakh into 0.2278, which is 4 lakh into 2278 upon 10,000, because there are four decimal places, the zeros will get cancelled. So this will be 2278 into 40. You have to multiply this, and whatever answer you get, that will be in rupees. Okay, so this is question number 5. Question number 6 is of the similar category. The only thing they are mentioning over there is ordinary annuity. Ordinary annuity is nothing but annuity immediate itself. Fine. So that is question number 6 for you all. Let us go to question number 7. Question number 7 is of a different category, right? The formula and all will obviously remain the same, but then we need to address it differently, right? Just a second. Hmm. So let me take you to the next problem. That is question number 7. A lady plans to save for her daughter's marriage. Okay, so she wants a certain amount after a period of time. So what is that amount? That is also given. Okay, that amount is rupees 4,64,100. Okay, so A is equal to 4,64,100. Now many of you might be wondering why I have written A and not A dash. A is for annuity accumulated value in annuity immediate. A dash is the accumulated value or future value in annuity due. But then this problem does not mention anything. So they are just saying ki what amount should she invest every year. So at the start of the year or at the end of the year, nothing is mentioned. So this problem is of annuity immediate. Okay. So A is given to you, then n is equal to 4 years, so this amount should be ready after 4 years. So 4 years, 4 installments she will save somewhere. Okay, I is equal to 10%, that's given in the problem. Okay, so we are supposed to find out C. Okay, what amount she should invest every year. So that's an installment that she has to keep somewhere in some bank or some finance company, so that she can get a return of rupees 4,64,100. Okay, so A is equal to C by I, 1 plus I raised to n minus 1. C is equal to, that is what we don't know basically. So A is equal to 4,64,100. C upon I is 10%. Okay, so 1 plus 10% raised to 4 minus 1. So 4,64,100 into 10%. We'll do cross multiplication. This goes over here. C 1 plus 10 upon 100 raised to 4 minus 1. This also I'm going to write this 10% also is 10 upon 100. Okay, so this will be 10 plus 1 11, 11 upon 10, this round bracket, it will be 11 upon 10, which is 1.1, right? So 4,64,100 into 10 upon 100. C 1.1 raised to 4 minus 1. So this is 0, this is 0. Okay, the zeros are getting cancelled. 4610 is equal to C 1.4641. Now this value is given to you in the problem. In the boards also they will give you this particular value. 4 lakh 64, no, that's not 4 lakh, that's 46,410 is equal to C upon 0.4641, right? Okay, so C into 4641 upon 10,000. So this goes over here, this comes down. So 46410 into 10,000 upon 4641 is equal to C. This is 10. C is equal to 1 lakh. So she should invest 1 lakh every year for 4 years, so that along with the interest, after 4 years she'll be able to accumulate 4,64,100. Okay, so it's a kind of financial planning. Okay, question number 8 is of the similar category, so we'll not solve it, but then we'll certainly discuss it. A person wants to create a fund of 6,96,150 after 4 years of at the time of his retirement. So in future he wants to accumulate a sum of 6,96,100, 150, sorry, right? And after 4 years he has to accumulate this. Okay, so every year he has to keep a fixed amount in a bank that gives him interest of 10%. So I is equal to 10%, right? And how much he should invest every year. So C is asked. Installment that has to be put into the bank every year, that is annuity. Okay, and annuity will consider over here as immediate. See, they are very clear over here. He decides to invest a fixed amount at the end of every year. So at the end of the time period, whenever it is mentioned is annuity immediate. So it's very clear in their communication. Okay, to us. That was question number 8, right? We'll, we'll proceed with question number 9. Okay, question number 9. Find the rate of interest compounded annually if an annuity immediate at 20,000 per year amounts to 2,60,000 in 3 years. So they are asking the rate of interest I. Okay, annuity immediate of 20,000. So annuity is nothing but C, and they are mentioning annuity immediate. Okay, they are clear in this particular problem, and it amounts to 2,60,000 in 3 years. So the future value is 2,60,000 rupees, and all you need to write. I might not write it over here, but then you just mention it. N is equal to 3 years, which is 3 installments. So A is equal to, I should say, C by I, 1 plus I raised to N minus 1, 2,60,000, 20,000 upon I, 1 plus I raised to 3 minus 1, 2,60,000 into I upon 20,000. Okay, so the zeros are getting cancelled. I cross multiplied over here basically. 1 plus I the whole cube, that is A plus B the whole cube. You should know the formula. A cube plus 3A square B plus 3AB square plus B cube, and this minus 1 is also there. Okay, so the left hand side in this calculation, this becomes 13I. Okay, this is 13I equal to 1 cube is 1, 3I, 3I square, I cube minus 1. So I'll just write all these terms. 1 plus 3I, 3I square plus I cube minus 1. So 1 and 1 getting cancelled. Let's take I common over here. 3 plus 3I plus I square. Okay. I is also getting cancelled over here. So I square plus 3I plus 3 is equal to 13. I square plus 3I plus 3 minus 13 is equal to 0. I square plus 3I minus 10 is equal to 0. You need to factorize this. Okay, so I square plus 5, splitting the middle term, equal to 0. It's a quadratic equation. Okay, so I plus 5 minus 2, I plus 5. Okay, equal to 0. I minus 2, I plus 5 equal to 0. That gives me the value of I as 2 or I as minus 5. The second case is discarded because we are not considering depreciation over here. The value is increasing. Okay, so I ka value is 2. Now I is equal to rate upon 100 in this particular chapter. So I is equal to 2, that is rate upon 100. Therefore the rate is 200%. So if you miss out on this particular step, everything will go wrong. You cannot just end at I is equal to 2 and that's the final answer. No, that's not the case. I is equal to rate upon 100. That this logic will have to apply. Okay, let us go to the next problem. That is question number 10. Find the number of years for which an annuity is paid at the end of annuity of 500 is paid at the end of every year. So annuity is paid, annuity of 500, annuity C, annuity is paid at the end of every year. So this becomes annuity immediate, okay, right? And the accumulated amount works out to be 1655. So 1655, n is equal to 2. 2 years is, no, they have not mentioned 2. We are supposed to find out n ka value. Okay, so I is mentioned. I is equal to 10%. It's given in the problem. Okay, so see, a is equal to c up c by I. ये problem में find out क्या करना है? We have to find out the number of installments over here, number of years. Okay, so 1655, 500 upon I, 1 plus I raised to n minus 1. We can put the value of I as 10%. Let's put the value of I as 10% over here. So 1655, 500 upon 10%, so that we can cross multiply this values on the left hand side. That will be a better option. Okay, and this is 1 plus 10 upon 100 raised to n minus 1. This I have cross multiplied. Okay, 10% again I'm going to write it as 10 upon 100. Okay, and this will be cancelled over here. Fine. Now this also zeros will get cancelled. The value of this round bracket is 11 upon 10. To take the LCM over here, 10 plus 1, 11, 11 upon 10. 11 upon 10, we'll keep it as it is. 11 upon 10 raised to n minus 1. Okay, so 1655 upon 3 zeros I've got. Okay, I think I've made a calculation error. 1 second. Yeah, this is 500. I've written my mistake. 100. Okay, excuse me for that. 11 upon 10 to n minus 1. Reduce this with 5. 5 threes are 15. 5 threes are 15 and 1. And this is 1000. 11 upon 10 raised to n. Now this cannot be used further. So what we'll do is we'll add minus 1 on the right left hand side. 331 upon 1000 plus 1. 11 upon 10 raised to n. 1000 plus 331. That is 1331 upon 1000. 11 upon 10. Now see, this 1000 is 10 cube. 1000 is 10 cube, right? So what is 1331? 1331 has to be 11 cube because number 11 is present over here. It has to be 11 cube. So they will give you problems of such category where certain things will match up. Okay. So by comparing, we can write n is equal to 3, which is 3 installments. So 3 years we should write over here. That's your final answer. Okay. Let us go to question number 11. Question number 11. Find the accumulated value of annuity due. So they are asking A dash this time because they are saying annuity due. So the accumulated value in annuity due is not A but then A dash. Okay. Annuity due of 1000. So annuity is nothing but C. 1000. Okay. N is equal to 3 years. So 3 installments. I is equal to 10%. Okay. So A dash C 1 plus I upon I, 1 plus I raised to n minus 1. Okay, so 1000, 1 plus 10% upon 10%, 1 plus 10% raised to 3 minus 1. So 1000, 10 upon 100, 1 plus 10 upon 100. Okay, 1 plus 10 upon 100. I hope you're understanding all calculations over here. Okay, I'll take this 10 in the numerator because it is denominator's denominator, and in this round brackets I'll take LCM, right? So this is 1000 into 100 upon 10. Then this will be this round bracket will be 100 plus 10, 110 upon 100. Okay, so this 100 and 100 will get cancelled. Inside the bracket also there is one round bracket, 110 upon 100 raised to 3 minus 1. More zeros are getting cancelled, so this will be 1000. Okay, 1.1 raised to 3 minus 1, 1000. 1.31 raised to 3 is 1.331 minus 1, so this is 0.331. 1000 into 331 upon 1000, there are three decimal digits, so three zeros. 1000 and 1000 will get cancelled. Okay, so just a second, I think something has gone wrong. Yeah, I've missed out on this 11, so this will be 11,000. Okay, 1000 into this 11 is 11,000. Okay, so this is three zeros and three zeros are getting cancelled, and then 11 into 331. 11 into 331 is nothing but 3641. Okay, so this is the value of A dash. Final answer, present it well along with rupees and everything, give all the units. Okay, so that was question number 11. Let us go to question number 12. Question number 12. Okay, a person plans to put rupees 400 at the beginning of each year. So he's planning to put 400 at the beginning of each year. So it's at the beginning of the time period. For 2 years he's going to do that. So this is the annuity, but then this is annuity due. Okay, uh, n is equal to 2, I is equal to 2%. Okay, n is equal to 2 installments. Find the amount that will be accumulated after 2 years. So this problem also they are asking A dash. Okay, accumulated value of annuity due, A dash. So A dash is equal to C1 plus I upon I, 1 plus I raised to n minus 1. You can use this formula and get the answer. The calculation is similar, exactly similar to the previous problem. So there is no change in the calculation. Okay, so I've just given you the hint. You can practice this problem on your own. Okay, let us go to the next problem, that is question number 13. Now this is a very simple problem. The present value of annuity due of, find the present value of annuity due. So they are asking P dash, present value of annuity due, P dash. Okay, paid quarterly. Okay, compounded quarterly for 1 year. So I is equal to 32%. Quarterly का problem है, so divide by 4, rate को divide by 4 करो. N is equal to 1 year. Okay, so 1 year into 4. There are 4 quarters in a year, so 4 installments. So P dash is equal to C 1 plus I upon I, 1 minus 1 plus I raised to minus N. Okay, so they are asking present value, right? Present value is P, but then why I'm writing P dash? Because the problem is of annuity due. They are mentioning in the problem. So 600 is the annuity, right? C is equal to 600. I did not mention that. Rupees and all you can write. Okay, annuity due of 600. So 600 is the annuity. Upon I is nothing but 8%. 1 plus 8%. 1 minus, just write down the formula very clearly for you all. 1 plus 8% raised to minus n. So n is equal to 4. Okay, I'll write this 8% as 8 upon 100, 600, 8 upon 100. Okay, one plus 8 upon 100, right? and this will be 1 minus 1 plus 8 upon 100 raised to minus 4. So 100 will go up, 600 into 100 upon 8, 108 upon 100, 100 is getting cancelled, 108 upon 100 raised to minus 4, right? So 600 upon 8 can go on reducing, but then just look at this, how I'm doing this. 8 I'm writing as 2 into 2 into 2, easy for calculation, and this is 1.08 raised to minus 4. So 2 into 300, 2 into 54, 2 into 27, so this will be 8100. Okay, and this value is 1 minus 0.7350. 8100 into 1 minus 0.7350. If you subtract this, 0.2650. 50 upon 10,000, because there are 4 decimal digits. The zeros are getting cancelled. This 2 more zeros are getting cancelled over here. So 81 into 265, that you can do, that is 21465. You multiply 81 into 265 upon 10. So this is rupees 2146.5. This is your present value P dash. Okay, fine. Let us go to question number 14. Question number 14. Annuity immediate is to be paid for some years at 12%. So the problem is clearly stating that it is of annuity immediate. Present value of the annuity is 10,000. P is equal to rupees 10,000. Accumulated value is 20,000. A is equal to rupees 20,000. Find the amount of each annuity payment. So they are asking C. Now this is the first problem in which present value and accumulated value are together in the problem. So what is the relation between A, P and C? So we have a formula, 1 upon P minus 1 upon A is equal to I upon C. Okay, so 1 upon 20,000, sorry, 1 upon 10,000 minus 1 upon 20,000. I is 12% upon C. We'll take LCM on the left hand side and multiply this by 2 and multiply this by 2. So this will give me 2 upon 20,000 minus 1 upon 20,000. Okay, 12%. So 12 upon 100 C. Right hand side becomes 12 upon 100 C. Okay, so this calculation will give you 1 upon 10,000. We have taken LCM, 12 upon 100 C. Cross multiply 100 C is equal to 12 with 4 zeros. C is equal to 12 with 4 zeros upon 100. Zeros are getting cancelled. Rupees 1200. Okay, so that's the answer of your question number. One second, I just made a small error when I was changing the slides. The LCM is 20,000. Sorry for that. So this is 20,000. This is also 20,000. Okay, so this will be 100 and this will be 12 into 20,000. Okay, so this will be 24 with 4 zeros. Excuse me for this, very sorry. 2400 is the answer, right? Let us go to question number 15, 1-5 of the exercise, the second last problem. Annuity immediate is paid for 3 years with annuity immediate problem. Okay, 3 years, n is equal to 3 years, 3 installments, I is equal to 10%. Okay, right? Then present value P is rupees 24,000. Okay, what should be the accumulated value? They're asking A. Okay, after 3 years. So A is equal to P 1 plus I raised to N. This is compound interest formula. A very simple problem. This can be asked for one marker also. 10% raised to N. N is 3. 24,000. 1 up 1 plus 10 upon 100 raised to 3. Okay. So this is equal to 24,000 into, this will be 11 upon 10 raised to 3, right? So 11 upon 10, that is 1.1 raised to 3. That value is given to us. Okay, 1.331. Okay, so 24,000 into 1331 upon 1000. Just multiply this and get the answer. Fine. That was your question number 15. Okay, let's move on to question number 16. The last problem of the exercise, which we will complete right now. Um, Question number 16. Okay. A person sets up a sinking fund in order to have 1 lakh after 10 years. So person requires 1 lakh in the future. N is equal to 10 years. Okay. What amount should he deposit biannually in the account that pays him 5% per annum compounded semi-annually? So this is biannually, semi-annually is a half yearly problem. Okay. So 10 years will be multiplied with 2, that is 20 installments. I will be 5% upon 2, which is 2.5%. Okay. So A is equal to C by I, 1 plus I raised to N minus 1. Okay. And we have the values. So this problem is of annuity immediate, because what amount should be deposited biannually? So at the start of the 6 months, at the end of the 6 months, it's not really mentioned over here. So this is annuity immediate. 1 lakh is equal to C by I, 2.5%. 1 plus 2.5% raised to N. N is 20 minus 1. So 1 lakh into 2.5%. C. Okay. 1 plus 2.5 upon 100 raised to 20 minus 1. Okay. I've cross multiplied this 2.5% and here I'm taking 22.5 upon 100. So this will be 25 upon 3 zeros, because percentage has 2 zeros and there is one decimal digit. So one more zero is, put over here in the denominator. So this will be, this round bracket will be 100 plus 2.5. That is 102.5 upon 100 raised to N minus 1. This is 2500, which is equal to C, two decimal digits, the point will shift to two decimal places towards the left. All these techniques you should know. Whenever it is division, the point shift towards left. Multiplication, it will shift towards right. Raised to 20 minus 1. Okay, so 1.675 minus 1. This value is given in the problem. They have to give this value, because how is it possible for you to calculate such big numbers? Okay, so this will be 0.675 in the round square bracket. C into 0.675, so 2500 is equal to C into 675 upon 1000. 2500 into 1000, cross multiply this, upon 675 is equal to C. Okay, okay, so we'll reduce this with 5. 5 5s are 25. Okay, 5 1s are 5. 675 divided by 5, you can do it separately also, instead of reducing, so that there is no calculation error. So 675 divided by 5, I'm also doing it at my end, 135. Now this is further reducible. 5 into 100, 5 2s are, this is 27. So C is equal to 1, 2, 3, 4, 5. 5 zeros upon 27. So if you divide this, you have to divide this, right? With proper division method. So this will give you rupees 3703.03. 0.70, sorry. Okay. So that is it. This is how the problem is. Okay. That completes your entire exercise. In the second session of annuity, I'll be discussing the miscellaneous problems, but then you can practice all 16 problems from this particular recording. Okay. Thank you.